Hi, it's Emma and I'm back with another video. Today's video is speaking about structures. So the whole topic of bonding is actually called bonding and structures, and I think it sounds a lot more complicated than it is. So structures are just what you make after the bond. So when you have an ionic bond, it makes an ionic structure. When you have a covalent bond, it makes a covalent structure. The only thing you've got to remember is, in a video which I'll link below about giant covalent structures, they're not the same, or the structures don't have the same properties, the same characteristics as simple molecules. So when you get an ionic compound, an ionic bond makes an ionic structure, then they generally take the properties as being quite similar for ionic compounds, but there's two different types of properties when we look at covalent. So I'll start with ionic compounds. First of all, I want you to recognise, and this is the only way because I haven't printed it off, I want you to recognise this diagram, which I'm really hoping you can see. Hopefully, that is a giant lattice, or an ion. It's a lattice. So when you think of an ionic compound, that's what you need to think of it looking like. The positives and the negatives, all in a very, very structured pattern. So if you were to look at some table salt, which is sodium chloride, that's an ionic structure. The positives would be the sodium and the negatives would be the chloride, and they're in a fixed position like that. So if you see that picture, that diagram, that represents an ionic structure. Other things you need to know about them: they have very, very high melting and boiling points. Think about salt, table salt, that's an ionic structure. That's a solid at room temperature. If it's a solid at room temperature, it's got a high melting and boiling point. Another thing you've got to know about them is when they're solid, when ionic structures or ionic compounds are solid, they do not conduct electricity. However, if you were to melt the ionic structure, so if I got salt and heated it up to its melting point and I got it into a liquid, those ions that were stuck in that very strict pattern, they then move and become free-flowing. If you have free-flowing ions, that means electricity can get through them. So ionic structures, when they're solid, do not conduct electricity, but when you melt them or even dissolve them in water, it's much easier to dissolve salt than melt it, because you just put it in some water, but not all ionic compounds will dissolve in water, but most will. And if they dissolve in water, they are in a liquid form. The ions are free moving, which means they will conduct electricity. And I think that's about it, really. They're held together by really strong bonds between the oppositely attracted ions. So that's ionic structure. High melting and boiling points. Only conducts electricity when molten. If you've heard that word molten, that means liquid. Now I'm going to move on to covalent structures. So you can have a simple molecule and a giant covalent structure. In general, the simple ones are the ones with a formula. So H2O, just hydrogen, H2, O2, they've all got formulas. Giant structures do not, other than one, which you only really need to know about for higher. But CO2. These are all simple molecules of a covalent structure, and you're going to identify that because it's actually got a formula. The rules for these ones are, and I have mentioned it in another video, if you have a covalent bond that makes a simple covalent structure, they are all gases and liquids at room temperature, which means they have low melting and boiling points. And another thing is they do not conduct electricity at all. So there's no free moving ions or anything like that. And that's all you need to really know. The next one, which goes into it in more detail on my giant covalent structures video, they're giant covalent structures. I'll just speak about it briefly, but that video will help you a lot more. You've got generally giant covalent structures, they do conduct electricity, except for one. The only one that doesn't is diamond. And if you look at that video, it'll make sense to you. And if you look at diamond, graphite, they're all solid at room temperature. If something's solid at room temperature, it has very high melting and boiling points. And that's it really. I'll only be repeating what I've done in another video if I go into them more. So I just want you to know that structures are the thing that's made after the bond. You can get an ionic structure, a covalent structure, and a metallic structure as well, which I'll also link the metallic bonding video, because what are the properties, what are the characteristics of a metallic structure? Well, they're solid at room temperature, so they have high melting and boiling points. They're ductile, you can pull them into a wire. They're malleable, you can bang them into shape. They're good conductors of electricity and good conductors of thermal heat. All right, thanks for watching, and I'll see you next time.